Day 2, we are going to look at solving linear systems by graphing. Again, just make sure we really have it down, and then we'll move on tomorrow. Warm up. The sum of two numbers is 6. The difference between the two numbers is 2. Can you figure out those two numbers where the sum is 6 and the difference is 2? All right, so we'll discuss that in class, many ways to figure it out, but I won't go over the answer right now. Instead, we're going to move on. We're going to look at solving linear systems by graphing. Again, what is a system of equations? It's looking for, we're looking at two or more equations that have the same variable. Okay, there are 3 methods for solving a system of equations, and we looked at the first one yesterday. The first one is by graphing. And then tomorrow we start the second method, which is by substitution. And also this chapter we look at solving by elimination. So we'll be looking at these 3 methods in detail this unit. All right, so again, today we're going to review the graphing method. So here's the first example. It says the sum of two numbers is 6. The difference between the two numbers is 2. What are the two numbers? Okay, so we can call our two numbers x and y are the two numbers, I'll say. So let's make an equation stand for each. So the sum of two numbers means add them up is 6. The difference between the two numbers is 2. Now to graph this, we'll want to get y by itself so we can see the slope and the y-intercept. So for the first one, we can take y and subtract x from each side and get y equals 6 minus x. For the second equation, we can add y to each side and subtract 2, so we'll get y equals x minus 2. So let's talk about slope and y-intercept for each of these. So for the first graph, the slope is -1, and the y-intercept, I'll call it the b value, is 6. For the second graph, the slope again is 1, but positive this time, and the y-intercept is -2. All right, so let's graph these. The first graph, start at 6, 1, 2, 3, 4, 5, 6. Slope of -1. Okay, so there's the first. The second one, we start at -2, and the slope is 1. Okay. And we learned yesterday when you solve a system, we're looking for that point of intersection. So here, the point of intersection is 1, 2, 3, 4, 2. In this case, those happen to be our two numbers. These two numbers have a sum of 6 and a difference of 2. What can you do if the point of intersection is hard to pinpoint? We're going to use technology to graph. You will have to adjust your window to see your lines sometimes. Keep your domain and range in mind when doing so. All right, so I'm going to pull up my graphing calculator. While I wait for that, we're going to solve a system by graphing on the graphing calculator. So example 2, you're looking at buying a new iPhone XS, Verizon S2 plans that give you 5 gigs of data and unlimited text and calls. Okay, so here's the first plan. Lease the phone for about 67 a month and pay $50 a month for voice and data. You can buy the phone from Apple for $1,000 and pay $55 a month for voice and data. Okay, so here's what is the independent variable? So that would be time, right? So every month how much you're paying. So x would be number of months. And here the dependent variable would be cost, because your cost depends on the time. All right, let's write the two equations. Okay, so plan 1 I'll do in blue. All right, so y equals, how much do we lease? Okay, so it's 41,667 a month plus 55 a month. So every month, here's what we're paying. So if we simplify that, that would be 96.667 per month that you're paying. Plan 2, we would buy the phone. So we do have a y-intercept here, $1,000 at first, and we pay $55 a month. So the question is, which is cheaper, paying $96 and about 67 cents a month, or paying that $1,000 up front, but then it's cheaper at $55 per month? Okay, so again, we could graph this and see the point of intersection, talk about it. But let's use our graphing calculator. So this gives you the steps to do it right here. Okay, so we're going to type in, I'm going to open a graph page, or you can do a new document, add a graph page. I'll just use Scratchpad calculator. Oops. Okay, so the first equation was that 96.667 per month. We hit enter, and then hit tab to type in the other one, in which we pay 1,000 plus, ooh, I just erased my last one. Okay, so this should have been in X, okay, here it is, 1,000 plus $55 per month. Okay, so if you don't see it, let's think about what our domain and range is. So menu, let's go to Windows Zoom, and then you can zoom fit your graph usually, but let's play with the window settings. Okay, so X is number of months, so we're going to start at 0 months. I'm actually going to go a little bit left of 0 so we get like the full graph in. And again, this is time, so let's go up, like, I don't know how many years. Do 4 years? 12 times 4, 48. All right, so that means 4 years. We know our cost. The minimum is at least $96 a month, so I'll just start at 0. And then we know for a maximum, our cost is going to be well over 1,000 because that second one starts at 1,000, so I'm just going to go to 2,000. Okay, so that's how you can use domain and range to kind of adjust your window. And you can see I didn't get it really as well as I wanted to. It goes a little bit higher. So again, we can go to menu, window zoom, and you can fix your window settings. You can zoom in and out. You can just grab the page and move it. So if I show you that, I can hold on to that middle OK button and grab it. Okay, so now I found the point of intersection. All right, so to find that, there is a tool on our calculator to calculate that point of intersection. So we're going to go to Menu, Analyze Graph. We're looking for the intersection. Lower bound just means go to the left of your point, upper bound to the right, and there's that point of intersection. So let's write that down and talk about what that means. So it's 24 and then 2.32E3. So let me write that down. So it was 24 and 2.32E3. All right, so first, let's talk about this E thing, scientific notation, which means move the decimal 3 places to the right. So if we do that, we get 2,320. All right, let's talk about what it means in the context of this problem. It means after 24 months, the phones both cost $2,320 total. I close up parentheses. Okay. When would you choose plan 1? And so if we take a look again at our graph, plan 1 was the blue one. Oh, sorry, I minimized that. All right, so it's everything up until 24, so from 0 months to 24 months. Plan 1 is cheaper. At 24 months, they're tied. And then after 24 months, the second function where you buy your phone first becomes cheaper. So if you plan on keeping your phone for more than 2 years, plan 2 is the way to go. So let's write that down. Okay, so you would choose plan 1 when if you had your phone from 0 to 24 months because it's cheaper. So we could say if your time was less than 24, it's cheaper. When will you choose plan, the second plan, plan 2, I guess I forgot a 2 here. So plan 2, we would say we would choose it when the time is greater than 24. At 24, it doesn't matter. So 24 months, you could do either phone, it costs the same. But this would be cheaper after 24 months. Okay, so today you're going to practice solving systems by graphing. So do this on your graphing calculator. You can also make a table to do that. And then you have this system of equations target practice. It says match each system to the target UFO that it locks on by solving by graphing. It may help to graph each system in a different color. So for example, let's look at just these lines right here. So we're going to graph x plus 6. So that y-intercept is 6. The slope is 1. But I can't go any more up, so I can go backwards and go down 1 over 1. And you can see that when you do that, it shoots UFO 6. Oh, but we're looking for where it crosses for both. Okay, so then we do have to graph the second one. I'll keep it both in red. Here the y-intercept's -4. and our slope is -1, so we're going to go down 1 over 1 in each direction. But if I go backwards, I go up 1 over 1 in each direction. Okay, so if you look at this, the first system gives me UFO 6, so we'll put the UFO here. So again, you're just graphing each system of equations, and you're seeing where do they cross.